And there we go. All right. Yeah, we want to set them equal to each other because since these two segments are equal, that means this is an angle bisector here. So these angles are equal. So V plus 68 equals 5V. And then we would subtract V from both sides to get 68 equals 4V. And then we would divide by 4 on both sides to get that V is 17. And then we're done. All right. So that was kind of still another problem like we were doing the last couple of days here with angle bisectors and perpendicular bisectors and all that good stuff. Today, continuing on with 6.3, we're going to talk about medians and altitudes. So it's two more special segments of triangles. We want to be able to identify them and use them to find missing measures and things like that. Given all four options now, angle bisector, perpendicular bisector, median, and altitude, we want to be able to identify all four of those. So let's get started and talk about what exactly is a median and an altitude. So if you don't have your notes out, go ahead and grab those. And here we go. So 6.3 medians and altitudes of triangles. Okay. So a median, you might have heard of a median of like a set of numbers, right? Like it's the middle number. So a median, we talked about triangles. It's pretty similar. It has to do with the middle. So their technical definition for a median is a segment from the vertex, or from a vertex, any vertex, to the middle of the opposite side. Or the midpoint of the opposite side, if you're thinking about it in terms of coordinates and whatnot. Okay. So for example, if I have a segment that goes from this vertex to the middle of the side across from it, that would be a median. And any given triangle has three medians. I could draw three different medians in this picture. I could get one from this corner to the middle of this side and from this corner to the middle of that opposite side there. Okay. So with medians, we want to be able to recognize them, either in this fashion or if you see something like this, where they tell you that this is 5 and this is also 5. This would be another representation of a median. Or you could see it as A, B, C. And then they tell you that DB is congruent to DC. That would be another way that you could see a median. So anyways, that's how we would want to look for medians to identify them. And then a type of problem that we might see with a median We might see a picture like this and be told that PS is a median. Find the length of SR. Okay. So again, this is going to be another thing where we set things equal to each other. Kind of sensing a theme in this chapter where a lot of times things are equal. If PS is a median, since we know that, we can mark these two things as being the same length. So then we can just set 6x plus 2 equal to 4x plus 10. And then we can start by subtracting 4x from both sides. So we get 2x plus 2 over there, and just 10 left over on the right. And then we would subtract 2 from both sides to get 2x equals 8. Divide by 2 on both sides to get x equals 4. So there's part of our answer, but then we want to make sure that we solve for what we're being asked to solve for, which is SR. So we would have to plug this back in to get 4 times 4 plus 10. Which is 16 plus 10, which is 26. So our answer, SR, is 26. Okay, so looking at anything that we've seen so far, are there any questions, any numbers we're not sure where they came from, steps that we want to go back to? Okay. If not, then we got one more type of segment that we want to talk about today, which is an altitude. All right. So when we think of the word altitude itself, what kind of things have we heard altitude described as? Or like where have we what kind of context have we heard the word altitude before? Height. Yeah. Like when you talk about the plane is flying at an altitude of 10,000 feet, or you know, the altitude of a mountain, or altitude sickness when you get, sick from being at too high of an altitude, or anything like that. Those are words that we kind of are things that we associate with altitude in real life. Well, altitude of a triangle is no different. Altitude is the height of a triangle, which is going to become important when we do the unit on areas and things like that. But altitude is also defined as a segment from a vertex to the opposite side that is perpendicular to the opposite side. Okay. So the two things that are important with an altitude is that it's going through a vertex and it's perpendicular to the opposite side. So if we have a triangle like this one, we might see an altitude that looks like that. Goes from a vertex and is perpendicular to the opposite side. Okay. Occasionally, you'll get a triangle like this, where if I want to draw an altitude from this vertex to this opposite side, I can't draw a line that's going to be perpendicular to this opposite side going through this vertex. So what I would do instead is I would draw a line straight down that would be perpendicular if I were to extend the opposite side a little bit. This would also be considered an altitude. So occasionally an altitude will be outside the triangle, but most of the time it will be inside the triangle. Okay. So these lines would both be altitudes. Okay. So kind of our main goal here, uh, for today anyway, is going to be able to identify all four of the segments that we've talked about so far. If we're just given pictures of those segments, we want to look at it and go, oh, that's a perpendicular bisector, or oh, that's a median. So that's what we're going to practice doing now. So I'm going to draw some triangles, and then we're going to go through and try identifying them. We'll also have none of the above be an option, but I'm going to start with just drawing the triangles, and then we'll draw some segments that go in them. One moment. Dogs heard someone at the door. There we go. Let's see, where were we? All right, so we got 6 triangles. We have 6 segments. We're going to identify all 6 of these. And so just to remind us, kind of our options, we have angle bisector, perpendicular bisector. We have altitude. We have median. And then we also have like none of the above. Okay. So looking at the first one, what do we think? What is that segment? Any ideas? All right, Marissa thinks median, Caleb thinks median. Anyone else think median? I would agree. Yeah, it's a median because it's going to the middle of the opposite side. These two things are the same. So this would be a median. Awesome, one down. All right, how about the second one? What do we think? We see the right angle. That kind of makes two options for us. It's either a perpendicular bisector or an altitude. What do we think? Yeah, perpendicular bisector. The only thing that disqualifies it from being an altitude is that it's not going through a vertex. It would have to be going through this point in order for it to be an altitude. But it's perpendicular and it's cutting this side in half. It's a bisector. So perpendicular, LAR, bisector. All right. How about the third one? What's going on there? Yeah, we've got an angle. And it's cutting the angle in half into two equal angles. So angle bisector. All right. How about the fourth one? What's going on there? Does this look like any of the ones that we've seen? We see a line coming across through a vertex, but these two segments are not equal. So is that a special segment? Yeah, none of the above. That one's not special because it's not cutting them equally in half or anything like that. So none. None of these. Not a special segment. All right, we're down to the last two. Number 5, what do we think that one is? Altitude. Yeah, we've got this perpendicular right angle symbol going on, but it's not a bisector. And it goes through a vertex. So if it goes through a vertex and is perpendicular to the opposite side, that tells us it is an altitude. All right, last one. What do we think? Any ideas on number 6? We see it's perpendicular bisector. This one actually has 2 correct answers. Anyone see what the second correct answer would be? So you're right, it is a perpendicular bisector. Yeah, it's also an altitude. Nice. All right, so this one's a perpendicular bisector and it's also an altitude. There's a couple of there's some different triangles where a perpendicular bisector could also be an altitude. So going from one corner, a vertex, to the opposite side and it's perpendicular makes it an altitude. And then the fact that it cuts the side in half also makes it a perpendicular bisector. What is going on? Sorry, my computer freaked out for a moment. Oh my goodness. All right, there we go. Now the computer has stopped freaking out, hopefully. Okay, anyways, that one is a perpendicular bisector and an altitude. That one had 2 answers. Most of the time, each segment will have 1 answer. Occasionally, it'll have 2. Okay, so that's pretty much everything that's new for today. We had medians and we had altitudes that are our new special segments. And then we want to, today's homework is going to revolve around being able to identify all 4 of those special segments on a triangle. So let's go ahead and take a look at that. All right, so today's homework is only one IXL section. We'll also have an exit ticket. But again, just one IXL today. So it should be pretty quick and easy, hopefully. But it's all about identifying our different special segments. So looking at IXL here, it's going to be just the same kind of problems that we did on our last 6 examples there. It'll say something like angle DEG. So DEG is congruent to angle FEG. Well, if these 2 angles are the same, that makes EG an angle bisector. Or it'll say WX is congruent to XY. So if these 2 things are congruent, then this ZX is a median. Okay, so that's what we're going to be working with. It'll say things like TVU is a right angle. TVU is this. This is a right angle. That makes it an altitude. Okay, so this is the part where if you have questions, please stick around. If you don't have questions, though, I'm going to post the exit ticket, and you guys can go ahead and get to work and have a good rest of your afternoon.